Okay, so for the first ones, we're asked to reduce. Now that's where we have to divide the top and bottom by the same number. So for 24 and 56, what can both of those be divided by? 8. Okay, if you see the 8, that's good. Otherwise, they're both even. You could have divided by 2. If divided by 8, that reduces to 3/7. 45 and 81, what can both of those be divided by? 9 works great. Again, if you see the 9, it works wonderfully. Otherwise, maybe you'll see that they can both be divided by 3. Divided by 9, you get 5/9. Perfect. 3 and 4, we're asked to convert to mixed numbers. Remember, that's how many whole objects and how many pieces left over. So 48/5, we have to ask, how many times does 5 go into 48? 9 times would be 45, so how much is left over? 3/5. So 9 and 3/5. Note that the numerator does not change there. Or not the numerator, the denominator does not change there. So 29/3 is going to become what? How many whole objects? 3 goes into 29 9 times again with how many? That's 27, so how many left over? 2/3. Again, the denominator does not change. To convert to improper fractions, again, the denominator is not going to change. Still going to be fourths, but we need to break the 7 whole objects into pieces. How do we do that? Perfect. 7 times 4, which is 28, and we add them back to the 3 that were already there, which makes 31/4. Good. 2 and 5/8 is going to become 21/8. Good. 2 times 8 is 16, plus 5 is 21. Any questions on those? So now I want to go back to these first couple we did. 24 over 56. And reducing it, and then we'll get to the other one in just a second. We reduced that by dividing by what we call common factors. Remember, we talked about factoring a couple classes ago. We did the factor trees, we talked about divisibility and all that. We found common factors and divided them out. What we were really doing there is canceling out common factors. So you could take these and factor them out. 24, we factored as 2 times 2 times 2 times 3. 56, 2 times 2 times 2 times 7. And as we reduce that, now we divided by 8 right away because you saw that. We could have divided by 2 several times. But to reduce this, all we're doing is canceling out common factors. There's a 2 in common. There's another 2 that they have in common. And another 2. So we're left with 3 over 7. The other one, the 45 over 81. If I factor those out, 45 is 3 times 3 times 5. 81 is 3 times 3 times 3 times 3. If we cancel out what's in common, cancel out a 3, cancel out another 3. What we're left with is 5 on top, 3 times 3 on bottom, which is 9. Which is what we got for when we reduced those fractions.
So you could use that tree thing we did yesterday.
That factor tree thing, yep. Yeah, that's where I got the 3 times 3 times 5. This is 45. That's divisible by 5. There'd be 9 left over. 5 is prime. 9 divides into 3 times 3. So that's where the 3, 3, and 9 come up from. Why am I bothering to show you this? Well, for some people might struggle reducing fractions, but it's the base of what's going on. Canceling factors is really what we are doing when we divide out those common factors. And the reason it's important is because, well, we might run into fractions like this. How do we reduce that? Well, x to the 5th is x. Is 5x's multiplied together, right? X to the 8th is 8x's multiplied together. If I cancel out common factors, I cancel out an x, another x, 3 more x's. Now, if everything cancels out on top, what do I have there? I have 1, right? Everything divides out. On bottom, x, and x make x to the third. So we're going to be able to reduce fractions with variables in them by using that factoring and canceling out common factors. So before we do that, let's use this to look at some of our rules of exponents a little bit. We've talked about this a bit, but let's go over it again. We're not going to go quite that extreme. I don't want to write out 12 x's. Let's go x to the 6th divided by x squared. What's the rule when you're dividing variables or exponents that have the same base? What do you do to the powers? Anybody remember? Somebody said it. Subtract. 6 minus 2 is 4. You get x to the 4th. And the reasoning for that is exactly what we just did with our fractions. X to the 6th is 6 x's multiplied together on top. X squared is 2 x's on bottom. And you can cancel out common factors. I cancel out an x, cancel out another x. So I have 4 x's, or x to the 4th on top, and everything on bottom divides out. So technically that's a 1. So x to the 4th over 1 is just x to the 4th. So as I cancel out here, every x on bottom takes away 1 on top. It makes sense that we're just subtracting the powers, because 2 of them get canceled out, so we're left with 4 out of the 6. So what if I have multiple variables, like x to the 9th, y to the 3rd, over x to the 5th, y squared? Well, I can treat each variable separately. So what am I going to get for the x's? 9 minus 5 is 4, x to the 4th. How about the y's? 3 minus 2 is 1, so y to the 1, or just y. So x to the 4th, y. I can throw in numbers. So 72, x to the 12th, y to the 5th, z to the 3rd, over 18, x to the 6th, y to the 4th. So what do I do with the 72 and 18? Do I get 54? No. I'm not subtracting numbers. I am still dividing here. So any numbers that I work with, I still have to divide. 72 divided by 18 is 4. Now I treat the variables each separately. X to the 12th divided by x to the 6th gives me x to the 6th. 12 minus 6 is 6. How about the y? Y to the 1, or just y. And what do I do with z? There's nothing down here to divide by. Okay, z to the 3rd. Nothing changes there. Perfect. Now, we saw before that we might have something like x to the 4th over x to the 7th. If I use the rules I've been talking about and divide that out, what's 4 minus 7? -3, right? I get x to the -3. And that is a legitimate answer. But if I do this out using my powers, my factors, x to the 4th is 4 x's. X to the 7th is 7 x's being multiplied together. If I cancel them out, cancel out an x, another one, and one more, everything on top cancels out, so that's a 1. I have 3 x's on bottom, x to the 3rd. X to the power of -3 and x, or 1 over x to the 3rd, are equivalent. That negative power means reciprocal. X to the 3rd. Think about it. If x to the 3rd means you multiply by x 3 times, x to the -3rd makes sense. That means you divide by x 3 times. So now with that in mind, we could look at something like this. So when I do this, what's 21 divided by 7? 3. X to the 5th divided by x to the 8th. What's 5 minus 8? -3. And then how about the y's? This is 7 and this is a 1, so 7 minus 1 is 6. Y to the 6. I could leave it like that. But I know that x to the negative 3 is equivalent to 1 over x to the third. So I could write it like that with 3 y to the 6th on top and x to the third on bottom. My math lab will occasionally ask you to express this with all positive exponents. So when you get this answer, you have to convert it to this. Basically what you're doing is just saying, okay, that's 3 times 1 over x to the third times y to the 6th. When you make them all fractions, you put them over 1 and you just multiply it out. 3 times 1 times y to the 6th is 3y to the 6th. 1 times x to the third times 1 is x to the third. Or you're just taking the negative power and you're putting it on bottom, making it positive. We're going to look at a few more examples of that because I know that's kind of confusing. Let's look at 18 x to the 11th, y to the third, z, over 3 x to the 9th, y to the 9th, z. Tell me what to do. Not everybody at once. What? 18 divided by 3 is what? 6. How about the x's? 11 minus 9 is 2, so x squared. How about y? 3 minus 9 is negative 6. We're going to convert that later. We're going to change it in a minute. How about the z's? Well, z divided by z divides out, just like 5 over 5 would divide out. They just cancel out. So there is no z in our answer. Now this is mathematically a perfectly correct answer. If my math lab asks you to express it with all positive exponents, what are you going to change? Well, 6x squared doesn't have to change. What happens to our y to the negative 6? It's over y to the positive 6. There's an alternative way of looking at this. Rather than dividing it out and then converting our negative powers, we could look at it as simply reducing a fraction. So let's take something like 9x squared over 12x. We're going to factor this out. 9 is 3 times 3 times x times x. 12 is 2 times 2 times 3. Then we have the x. What cancels out here? A 3 cancels out. Anything else? One of the x's. Anybody have any questions on how first of all, how I factored those? And then how I cancel anything out? Okay. What's left on top? 3 times x, so 3x. On bottom, well, 2 times 2 is just 4. So it's 3x over 4. What if we have something like 28 x to the 5th, y to the 7th, over 42 x to the 8th, y to the 5th. Well, if I want to reduce this, I can factor it out. 28, bless you. 28, if I factor it out, will be 2 times 2 times 7. What's going to happen with my x's? 5 x's, right? How many y's? 7 of them. Y to the 7th means 7 of them. On bottom, 42 factors out to be 2 times 3 times 7. Again, if you don't know where I'm getting those from, I'm doing a factor tree. 42 could be 2 times 21, 21 3 times 7, and that's it. 2 times 3 times 7. How many x's do I need down here? 8 of them. How many y's? 5. So let's cancel out. For numbers, what can I cancel out? 2 and a 7. Good. How many x's can I cancel out? 1, 2, 3, 4, 5. I'm left with how many on bottom? 3 of them. How many y's can I cancel out? 5, right? 1, 2, 3, 4, 5. I'm left with how many on top? 2. So on top here, I have 2y squared. On bottom, I have 3 x to the third. I want to look back at the original problem, and I want to try to find patterns here. The 2/3, if I just had the fraction 28 over 42, what does that reduce to? Both of those divide by 14. Give me 2 over 3. 28 over 42 just reduces to 2/3. So the numbers here are the same as I would get if I just reduced the numerical fraction. Well, how about the variables? Let's look at the x's. So I had x to the 5th over x to the 8th. In my answer, where did x end up at? In the bottom, right? Well, what about this in the beginning would indicate that x is going to end up on bottom? How would I know by looking at this? What's that? If I did 5 minus 8, it would be a negative number, yep. The other thing that shows me the larger power is on bottom, which would make it a negative number. It's kind of what you were saying. The larger power is on bottom in my original fraction. It's going to end up on bottom in my reduced fraction. So rather than having to do 5 minus 8 and get negative 3 and then say, oh, well, we'll put that on bottom and make it positive, I could just look at this and say, hey, the larger power is on bottom. It's going to end up on bottom in my answer. So then what's the difference between 5 and 8? 3. So it's x to the third, and it's on bottom because the bigger power was on bottom. Then we look at the y's. Y ended up where in my answer? On top, right? It ended up on top because the larger power was on top in the original problem. 7 minus 5 was 2. Well, let's look at that and see if that'll work for another example. Oh, let's see here. So if I look at this one, let's factor it out and do it the long way. Then we'll come back and see if that shortcut would have worked. So 24, if I do a factor tree, I get 2 times 2 times 2 times 3. And then 7 x's. Then 5 y's. And then 4 z's. 60, if I factor it out, I get 2 times 2 times 3 times 5. And then 3 x's. And 7 y's. And 9 z's. Ran out of room there. So what can I cancel for numbers? A 2, another 2, and a 3. So the numbers I'm left with 2 over 5. For x's, what can I cancel? 1, 2, 3. I'm left with how many on top? 4. So x to the 4th on top. What can I cancel for y's? 1, 2, 3, 4, 5. What am I left with on bottom? Y squared. And z's? And cancel out 4. I'm left with z to the 5th on bottom. Well, let's look up here. If I had just reduced 24 over 60 as numbers, what would I get? They can both be divided by what? 6 works. 24 divided by 6 is 4. 60 divided by 6 is 10. I can still divide by 2. Give me 2 over 5. Is that my numerical part down here? Sure is. If I took my x's, remember what we're talking about, looking at this, it indicates that x would end up where in my answer? On top. Why? The larger power of x is on top. It should end up on top down here. And it did end up on top. 7 minus 3 is 4. That's the power we have. X to the 4th. Now y, the larger power, is where in the problem? On bottom, right? Y to the 7th. 7 minus 5 is 2. We did end up with y to the 2nd on bottom. Z, the larger power, is where? On bottom. 9 minus 4 is 5. We get z to the 5th. So it appears as though that pattern holds true for other problems. So we can just use that to reduce our algebraic fractions. So we might have something like this. If I want to reduce this fraction, if we're told to reduce it, I'm going to take my 15 over 45 and I'm going to reduce it, the numbers, separately. What can I divide both 15 and 45 by? 15. 15 divided by 15 is 1. 45 divided by 15 is 3. So in my answer, I'm going to have a 1 on top and a 3 on bottom. I might not need that 1 on top, and I'll show you why in a second. For my x's, is my x going to end up on top or bottom in my answer? Bottom, because the larger power of x is on bottom. What power is it going to have? 3, x to the 3rd, because 11 minus 8 is 3. Where's the y going to end up in my answer? On top. What's its power going to be? Careful. This is going to be, think of that as y to the 1. 5 minus 1 is 4. So y to the 4th goes on top. Larger power was on top. 5 minus 1 is 4. Y to the 4th. Leaving it like this is not wrong. That's actually perfectly acceptable. Generally, we have 1 times y to the 4th, so we just write that as y to the 4th over 3x to the 3rd. What do you think? Not too bad? Well, let's have you guys try a couple. So we try one to start out with. Try that one in your notes, quick. So for the numbers, 9 over 30, what can both of those be divided by? 3. Give me 3/10. Can I reduce that any further? No. So the numerical part of my answer is 3 on top, 10 on bottom. What do I do with the x's? Okay, it's going to be top or bottom? Top, because the larger power is on top. X to the 8th is bigger than x to the 4th. Power will be 4. 8 minus 4 is 4. Where's the y going to go? Bottom, because the larger power is on bottom, and its power is going to be 1 or just y, because 6 minus 5 is 1. How many of you had that? Good. Let's try another one. Try that one in your notes quick. So if I reduce the numbers, 18 over 54, what does that reduce to? 1 over 3. Good, 1/3. So up here, my numbers are going to be 1 on top, 3 on bottom. Do I need the 1 on top? Well, at this point, we don't really know yet, right? So we're going to leave it there for now. What happens with x? On bottom, the larger power is on bottom. So it's going to be x to the 2, because 11 minus 9 is 2. How about y? Y to the third on bottom. 15 minus 12 is 3. 15 was bigger, so it goes on bottom. How about z? Yeah, z to the third and z to the third just divide out. So we did need the 1 on top, because we have to have something on top, and nothing else was going to be up there. So it's 1 over 3x squared y to the third. Any questions? If I have fractions like 3/4 and 1/5, and I need to have a common denominator, I need to figure out what that denominator is going to be. We talked a little bit about factoring, and we talked a little bit about least common multiples. LCM stood for least common multiple. To find the least common multiple of a number, we use all of the factors within each number. For example, if I want to find the LCM of 6 and 8, I factored each of those. If I factor 6, 6 is going to be what? 2 times 3. How about 8? 2 times 2 times 2. Any questions on where I got those factors? Okay. Do they have anything in common? Yeah, they have a 2, right? It's what's not in common that matters here. This one has a 3. The 6 has a 3 in it. The 8 does not. So I need to do what? I need to put a 3 down here. Now they both have that extra 3. This one has 2 more 2s, so I need to put 2 more 2s up here. Now 2 times 3 is 6, times 2 is 12, times 2 is 24. 2 times 2 times 2 is 8, times 3 is 24. 24 is the least common multiple of 6 and 8. Does that look familiar at all? A little bit? Okay. So now this example I gave you up here, 3/4 and 1/5. If I want to find the least common denominator, that is the same as finding the least common multiple. So I have 4 and I have 5. Factors of 4 are what? 2 times 2. How about 5? 5 is prime. So its only factor is itself. Well, it's not factorable, I should say, so it's just 5. So the top number, the 4, has 2 2s. I need to multiply by 2 2s down here. The bottom has the 5. I need to multiply by 5 up here. So I get 20 and 20. So 20 is my least common denominator. So if I have 7/8 and 5/12, can I find my least common denominator? Well, 8 is going to factor into what? 3 2s, right? 2 times 2 times 2. What's 12 factor into? 2 times 2 times 3. Good. Look at what they have in common. They have a 2 and another 2. So what's left? What do I need to put up here? The extra 3. What do I need to put down here? The extra 2. 2 times 2 times 2 is 8, times 3 is 24. 2 times 2 times 3 is 12, times 2 is 24. So 24 is going to be my least common denominator. Now, as I look at that, remember how we rename these. We have to look, what do I multiply an 8 by to make it into a 24? 3. So what do I have to do to the 7? Times 3 makes 21. 12 has to be multiplied by what to make 24? 2. So I have to do what to the 5? Times 2. So 5 times 2 makes 10. If you looked over here, by the way, I had to multiply the 8 by 3. I had to multiply the 12 by 2. That's what I have to use to rename my fraction as well. So the factoring actually tells you everything you need to know about renaming your fractions and finding common denominators. We're going to leave it at that for now. So I want you in your notes, try to find for me common denominator between 4/15 and 3/20. If I factor 15, what does it become? 3 times 5, right? What does 20 become if I factor it? 4 times 5, or if you reduce the 4 to 2 times 2, so 2 times 2 times 5, right? So the 5 is in common. What's this top number need? 2 more 2's. What's the bottom number need? A 3. If I multiply this back out, I get 60. Multiply this back out, I get 60. I always double check to make sure I get the same thing. So these are going to convert into 60ths. Now all I asked you to do is to find that common denominator. Let's go to the next step. What's this going to be up here? Careful. 16, good. 15 times 4 to make 60. So 4 times 4 to make 16. What's this going to become? 9, good. 20 times 3 makes 60, so 3 times 3 makes 9. Again, this was times 3. Times 2 times 2 is 4, so times 4. Well, how about a common denominator for this? There's your happy thought for the day, huh? So I have 8a squared. If I factor that, 8 becomes 2 times 2 times 2. A squared is a times a. 12a, well, 12 factors into 2 times 3, and then just the a. So I look at what's in common. There's a 2, and there's another 2, and then there's an a. What's this top one need? The 3. What's this bottom one need? 2 and an a. So that's 8 times 3 is 24 a squared. This is 12 times 2 is 24. A times a is a squared. So my common denominator there is 24a squared. What do I have to multiply the 8a squared by to turn it into 24a squared? Over here I multiplied by what? 3. So 3 times 3 makes that 9. What do I have to multiply the 12a by? 2a to make it 24a squared. So 12a times 2a makes 24a squared. 5 times 2a makes 10a. We have common denominators. I'm going to have you guys try one in your notes. Find the common denominators for that. Just find what the common denominator would be, and then we'll talk about the rest in a little bit. So if I factor 9x, 9 factors into 3 times 3 Then I have the x. What does 6 factor into? 2 times 3, and then x to the third is just 3 x's. What do they have in common? A 3 and an x. What's this top one need to have? A 2 and 2 x's. So times 2 is 18. X, and x is x to the third. What's this one need to have? The 3. So 6 times 3 is 18, and we have the x to the third. What do you think? Not bad? Okay. Next step. Fill in the numerators for each of those new fractions then, now that we found the common denominators. I'll pause it for a minute. So what's this become up here? 8 what? X squared. Good. I had to multiply by 2x and x, so by 2x squared. So 4 times 2x squared makes 8x squared. What's this become here? 15. I just had to multiply by 3 here. So times 3 and times 3 makes 15. Any questions? Okay, it is time for our break, so let's go ahead. We'll come back at about 4:20 or 4:30, start our second half.